Hi everyone, myself Konda Krishnudu, Assistant Professor of Physics, Department of Science and Humanities, MLR Institute of Technology, Hyderabad. In the previous week, we discussed about some of the basic concepts about lasers. What is laser? Characteristics of lasers, the process of absorption and emission, and Einstein coefficient, etc. Today, in continuation with that, I am going to explain about one more topic. So coming to today's overview of presentation, I am going to explain first about block diagram of a laser system. Block diagram of a laser system. After that, one of the important laser we are going to discuss, that is ND-YAG laser. So that we are going to discuss under the headings construction, working, and as well as applications, and finally conclusion. So these are the topics that I'm going to explain in this particular session. Now coming to block diagram of a laser system. So we know that a block diagram of a laser system consists of three parts. The three parts are: one is source of energy, the second one is active medium, the third one is resonating cavity. So on the left side you can observe the block diagram. So this is source of energy. We discussed one of the important topic called population inversion, which is the necessary condition to get a laser beam from laser device. Population inversion means we need to invert the populations of both ground state and excited state. In general, there will be more number of atoms in the ground state when compared with excited state. So to make N2 greater than N1 or to achieve population inversion, we need to supply particles from lower level to higher level. It is possible by giving energy from the external source. Giving energy from the external source is called pumping. That is done by the source of energy. So source of energy, the name itself implies that it supplies required energy to the particles of ground state so that they will move from ground state to excited state. The second part is active medium. So we know that a laser is a device which produces laser light or laser beam. So to get laser beam from laser device, transitions has to occur between various energy levels. All those energy levels will be available in the case of the second part, what is called active medium. Active medium is nothing but the medium in which population inversion takes place or the actual process takes place. So this is called active medium, or it is written as lasing medium. Now the third one is resonating cavity. So resonating cavity is nothing but an arrangement. It is an arrangement which is having two mirrors, one mirror on left side and the other mirror on the right side. So resonating cavity is an arrangement having two mirrors. One is fully reflecting mirror and the other one is partially reflecting mirror or partially transparent mirror. So in general, this active medium is always kept inside the resonating cavity. So to get a laser beam from laser device, all these three are required, and that we discussed here in the form of a block diagram. Any laser system consists of these three parts. Either it may be a solid state laser, liquid state laser, gaseous laser, dye laser, or semiconductor laser. Now we are going to discuss about ND-YAG laser. Our main topic of today's session is ND-YAG laser. What is ND-YAG laser? What is the full form of ND-YAG? So here ND stands for neodymium. So neodymium is a rare earth element. It is a rare earth element whose reactivity is very high. So that's why it is used here in this. And Y stands for yttrium, A stands for aluminium, and G stands for garnet. So ND-YAG laser is called neodymium yttrium aluminium garnet laser, and chemically it is written as like this: Nd-Y3Al5O12. So ND-YAG laser is a solid state laser. Why it is called solid state laser is ND-YAG rod is used as active medium. ND-YAG rod ND-YAG rod we are using as active medium, which is a solid. That's why this ND-YAG laser is called a solid state laser, and it is a 4-level laser. So as we discussed earlier, laser systems are divided into different types: 2-level, 3-level, and 4-level lasers. They have their own advantages and disadvantages. Now, this is a 4-level laser. ND-YAG laser is a 4-level laser. And coming to the ports, we know first port is source of energy. What is source of energy in this laser? Xenon flash tube. Xenon flash lamp serves the purpose of source of energy. Source of energy means which gives energy to the particles of ground state in order to move them from lower level to higher level. Active medium here is nothing but yttrium aluminum garnet rod. ND-YAG rod is used as active medium. And pumping method we are using in this laser is optical pumping. So as we discussed earlier about various types of pumping, one of the pumping mechanism is optical pumping. Optical pumping is the one where the particles of the ground state can be sent to the excited state by giving energy in the form of light. So what are the active atoms, active ions in this case? In this case, active ions are neodymium ions. Why we have to call them as active atoms or active ions is, between the energy levels of neodymium only we are going to get laser transitions. And as we discussed, optical resonator or resonating cavity in this case is nothing but glass tube surrounded by 2 mirrors on either side of it. One is fully reflecting, on the other side partially transparent. Generally they are coated with silver material. So it is a high power laser. ND-YAG laser is a high power laser. And nature of output. So it is available both pulsed and continuous modes. ND-YAG laser can be capable of producing both continuous and pulsed outputs based on the requirement. And the wavelength of output in this case is 1.06 micrometers. So wavelength corresponding to 1.064 micrometers corresponds to far infrared region. So generally they are invisible. Less. And finally, these are the characteristics of the ND-YAG laser. Coming to the block diagram, coming to the construction here, from this diagram we can understood source of energy in this case is flash tube. Flash tube is used as source of energy in this case, and this source of energy or flash tube is connected to power supply. And the second device here is active medium. Active medium is nothing but ND-YAG rod. This is ND-YAG rod. This ND-YAG rod, which is called as active medium, is kept inside the resonating cavity. So this is resonating cavity. Resonating cavity is an arrangement where it is having 2 mirrors. One is fully reflective mirror on one side, the other side partially reflective mirror. And in general, laser radiation or laser output comes from the partially transparent mirror, right? So as we discussed in the previous slide, it is a solid state laser, and neodymium ions are active ions in this case. Neodymium is used as dopant in this case. A small proportion of neodymium is added to YAG rod actually. That small proportion of neodymium as an impurity will change the energy levels of it drastically, as a result of which laser transitions are possible between these energy levels. Okay. Now, neodymium provides the laser activity, which is an active ion or active atom. It is capable of operating both under pulsed and as well as continuous mode. That is about the construction. Now, coming to the working. So, how ND-YAG laser will work? So, now we are going to discuss the working of ND-YAG laser in terms of energy level diagram. So this is the energy level diagram through which we are going to discuss the working. So here it is having different energy levels like E0, E1, E2, E3, E4. So generally energy is taken on y-axis here, and population is taken on x-axis, and E0 here is called as ground state. Among all these energy levels, E0 serves the purpose of ground state, whose lifetime is more, or which is very stable energy state. And whereas these E3 and E4 are called excited states. We know excited states are nothing but the energy states having smaller lifetime, around 10 power minus 8 seconds. Here E3, E4 are excited states. So here instead of energy level, we are observing like energy bands, right? So collection of energy levels is called energy bands. In this case, ND-YAG laser has broad absorption bands. Now E2 is metastable state. Metastable state means we know the excited state having longer lifetime. Generally, lifetime of excited state is around 10 power minus 3 seconds. So the role of this metastable state is very important in achieving lasing action or getting a laser beam from laser device. Now, so how to discuss the working of ND-YAG laser? So this is flash tube which is connected to the power supply. When we switch on the power supply, what happens is flash tube will glow. So in this case, flash tube will give white color radiation. White color radiation, that is non-monochromatic, means which is having so many wavelengths in it. So this light is going to fall on the active medium which we have taken inside the resonating cavity. So that light from the flash tube is going to fall on the ND-YAG rod. So in this ND-YAG rod, neodymium atoms are going to absorb. They are going to absorb energy. Based on that, they will move into the two excited states E3 and E4. Right. So some of the neodymium atoms move from E0 to E3, and some more will move from E0 to E4. Based on the amount of energy they receive, they will make a transition into either E3 or E4, and they are indicated clearly here. This is E0 E3 transition, where it is absorption corresponding to wavelength of 0.80 micrometers, and another absorption is there from E0 to E4, where it is absorption corresponding to 0.73 micrometers. So based on the amount of absorption or the energy they receive from the external source, they will make a transition from E0 to E3 as well as E0 to E4. We know both E3 and E4 are excited states whose lifetime is very less, and hence immediately they will fall into the metastable state after their lifetime is over. So particles from both E3 and E4 fall into E2. As a result of that, or at one moment, population in E2 will become very much greater than population of E1 due to transition of particle from E4 to E2 as well as from E3 to E2. At one moment, population increases drastically in this energy level E2. So at one moment, population inversion condition will be achieved between E2 and E1. As a result of that, all these particles will make a transition from E2 to E1. As a result of that, laser transition takes place corresponding to wavelength 1.06 micrometers. So after that, non-radiative transition takes place from E1 to E0. Again, the flash tube will glow. The particles of ground state will take energy. Again, they will make a transition from E0 to E3 or E0 to E4, and the process will continue. So that is how ND-YAG laser will work, or actually what happens inside the active medium we discussed in terms of energy levels. Now coming to the applications, ND-YAG laser has so many applications in various fields of science and technology. The first and foremost important is it is used in the industries. ND-YAG laser is used in industries. they are used in material processing such as welding, cutting, drilling, and also it is used in medical field. Most of the applications of NDYS laser exists in medical field. Particularly they are used in medical endoscopes to treat gastrointestinal bleeding, and they are used to treat skin diseases, that is they are used in the cosmetology. Also they are used in the ophthalmology, they are used for eye surgeries. So like that, NDYS laser has specific applications both in the field of industry as well as in the field of medicine. That is how NDYS laser plays a major role. Now coming to the conclusion, that's all for today, where we discussed about the block diagram of a laser system, and we came to know about various parts that exist inside a laser device. And after that, particularly we discussed NDYS laser, its construction, working, applications. And now in the next class, as a continuation to this, we are going to discuss about one more important laser device, that is CO2 laser. Thank you.